Alright, chemistry students. One last quick video to help you with nomenclature as per the request of a couple of my students is to figure out what to do when you're naming transition metals. So, if you have a compound that contains a transition metal, let's see something like FeCl2. It's important for you to be able to figure out what the charge is on this transition metal, because you need to be able to put the charge of the transition metal into the name. So the way that I've devised to do that is what I call the square method. So it's important to note that the only time that you'll use this is when you have a chemical formula and you need to find the name of that chemical formula, and that chemical formula contains a transition metal. So the only time that you'll use this is in a problem like this where you have the chemical formula and you need the name, and the chemical formula contains a transition metal. So the way this works is you need to balance you know that the charges are balanced within your ionic compound. So based on that, you can use the charge of the negative ion to figure out what the charge of the positive ion should be. Fortunately, we'll always know the charge of the negative ion. If it's just an individual element, like chlorine, we can gather its charge from the periodic table. And we know that chlorine has a charge of -1. So, the goal here is to find the total amount of negative charge, because that has to equal the total amount of positive charge because this ionic compound is balanced. So the way we do that is we take the negative charge of chlorine, we multiply it times the number of chlorines present, and that gives us the total negative charge of -2. So our first step is to multiply. And we start here with the charge of the negative ion. We then know that the total negative charge has to equal the total positive charge. Then we take the total positive charge and we divide it evenly among how many metal ions there are. In this case, there's only one iron, so 2 divided by 1 gives us a total charge of +2. So intuitively, it makes sense that it takes 1 +2 iron to cancel out 2 -1 chlorines in order to make even charge. That's the whole purpose of what we're doing, is to make it so that the amount of positive charge on the transition metal balances out the charge on the overall compound. And doing it this way will work. So we start here with the negative charge, we multiply, that's all, the total negative charge will always be equal to the total positive charge, then we divide. And then we end here. So because of that, FeCl2, because iron has a charge of +2, will be called iron 2 chloride. Now, if you have one with a polyatomic ion, let's say something like Fe2 parentheses SO4 sub 3, well, then you can do the exact same method. You know that the charge on sulfate is -2, either from your Nick the Camel sentence or just from memory. So 3 sulfates have a total charge of -6. That's equal to the total positive charge of +6, because this has to be a balanced ionic compound. Then we divide this total positive charge evenly among both the metal ions, because the metal ions will carry all of the positive charge. So 6 divided evenly into 2 gives us a total charge of +3 on each iron. So since each iron has a charge of +3, we call this iron 3 sulfate. Now, this is important because we need to be able to use Roman numerals in our compounds containing transition metals, because just saying iron sulfate is insufficient. The reason for that is because if we have iron that has a +2 charge, this would be a balanced compound of iron and sulfate. So both of these things can't be called iron sulfate because they're different chemicals with different properties. So it's important that we have different nomenclature available for them, and the way that we've chosen to do that is by putting a number in the name that corresponds to the total amount of positive charge on the metal ion. So that is doing the square method with transition metals in order to figure out what the total amount of positive charge is. I hope that helps. Good luck on your exam tomorrow. You should be practicing a lot tonight. You have plenty of practice to do. Godspeed.